Hello children, let's come back to our maths class. Today we are going to continue with our exercise 7.8. In the previous class we have completed with exercise 7.7 which was based on intervals of concavity and point of inflection. Yes children, I hope you have completed all your homeworks that I have given you in the previous class. So today we are going to continue with a new exercise 7.8. Get ready with your classworks. Take down your classwork. Write down today's date. Copy down exercise 7.8 and take down the first sum. Find two positive numbers whose sum is 12 and their product is maximum. Copy down the question. Find two positive numbers whose sum is 12 and their product is maximum. I hope you have taken down the question. Okay, let's start with the sum. So here what you have to find out, we have to find out two positive numbers. So we are going to take it as x and y. So write down, let the two positive numbers be x and y. So because we are asked about two numbers, so we are just going to take it as x and y. Now they have given you that the sum is 12. That means if I have the two numbers as x and y, their sum is going to be 12. So just mention here, given x plus y is equal to 12. This is given to us. Given x plus y is equal to 12. Now what we are going to do here is, we are just going to get the value for y from the given part. So this implies y is equal to, just take the x to the right hand side. So we get here 12 minus x. We have x plus y is equal to 12, and from x plus y is equal to 12 I have found the value for y which is equal to 12 minus x. Now just see here, we have to find out the function over here. So what is given to us? The product is maximum. So what is maximum? If whatever term comes with maximum or minimum will be considered as the function. So here they are saying the product is maximum. So I am going to take the function as the product. So if the numbers are x and y, what will be the product? The product will be x into y. So you have to assume the function as x, y. The product. What is maximum? The product is maximum. What is the product? X into y. So I have taken the function f of x is equal to x, y. So copy down the function f of x is equal to x, y. I hope you are clear how to identify the function. Now what we are going to do is, we are going to just go for the first derivative test over here. But before going to first derivative test, we have to just do one more step over here. In this function, we have two variables. So here is f of x and here we have y. So we are just going to change the function in terms of one variable, single variable. So I will write down here, this is equal to x 12 minus x. I will not keep it as two variables, I will make it as a single variable. This is 12x minus x square. X into 12, 12x, x into x, x square. So I get 12x minus x square. Okay. So now the next step is to go for derivation. So I take first derivative test, f dash x. 12x, very easy, 12 is a constant number, it is x, so derivative of x is 1. So I get the answer as 12, and derivative of x square is 2x. The 2 will come to the front and you have to take minus 1 over here. So 2 minus 1 will give you 1. So what is the derivative for x square? It is 2x. Okay, so this is minus 2x. So I have found the value for f dash x. F dash x is equal to 12 minus 2x. Now what we have to do is, we have to equate this f dash x is equal to 0 to get the critical value. So I just put here, f dash x is equal to 0 implies 12 minus 2x is equal to 0. 12 minus 2x is equal to 0. So what is the answer? 12 is equal to 2x. Therefore, 12 is equal to 2x. So find out the value for x. Therefore, x is equal to 12 upon 2, which gives you 6. So we have found the value for x, that is the critical value. So what we have done, we have a condition that the sum of the two numbers are 12. So we have taken x plus y as 12. And from the given part, we have found the value for y. And we have to find out what is the function in the particular question. So here the product was taken as maximum. So we have taken fx is equal to xy. So I don't want two variables. I have just made it as a single variable. So in place of y, I have put 12 minus x. So just open the bracket. So x into 12, 12x, x into x square. Now after getting the value for fx, you have to take the first derivative. So I get f dash x is equal to 12 minus 2x. So f dash x is equal to 0. We have to assume f dash x is equal to 0. And we have to just equate this with 0. So then I get the value for x. Clear? So I have found the value for x. Now what is the next step? We have to find out f double dash x. How to take f double dash x? Now we have f dash x, you have to derivate this again. If you derivate f dash x again, you will get the answer for f double dash x. Come on, complete till here. Try out f double dash x. Come on, find out the second derivative test. So what is f double dash x? F dash x is 12 minus 2x. So I'm going to take the derivative for this again. So derivative of 12, this is a constant number. So derivative will be 0. So no need to mention here 0. And what is the derivative for 2x? 2 will be 2 and derivative of x will be 1. And we have a sign here, minus sign. Yes, students? So just put here, this is minus 2. So I got the value for f double dash x. What is f double dash x? This is equal to minus 2. Now already we have used a concept in our previous exercise. If you have the value for f double dash x as negative, then it is maximum. Remember, if f double dash x is negative, here greater is 0, yes, it is negative. If it is negative, it is maximum. If it is positive, it is minimum. This is what you have to remember. So now here I got the answer minus 2, which is less than 0. So you have to say that it is maximum, because I have told you the product should be maximum. Yes, I got a maximum value. So just say that it is maximum. Is maximum. Okay, so now we have to just find out one more detail, because the question was to find out two positive numbers. I have found one value, that is x is equal to 6. I have found. Now we have to find out the value for y. And I know that y is equal to 12 minus x. So just put here y is equal to 12 minus 6. Therefore y is equal to 6. That's all. We have found the value for x and also we have found the value for y. So just complete the statement over here. Just mention, therefore two positive numbers are 6 and 6. Therefore two positive numbers are 6 and 6. So we have completed our first sum. I hope we were clear with the steps. So first of all, you have to identify what is given to you and you have to find out the function. After getting the function, you have to take the first derivative test. After getting the first derivative test, you have to equate with 0. When you equate with 0, you get the value for x. After getting the value for x, you have to find out double derivative, or that is second derivative. And from the second derivative, we come to know whether it is maximum or minimum. Then whatever is left out, you have to find it out. So here y was left out, yes children? So we have just found the value for y. So we have completed our statement by saying that two positive numbers are 6 and 6. Okay. The second sum will be a homework. And now you take on the third question. The second sum is the homework. The second sum is just related to this. Just understand the question. Some small changes and the product is given to you and the sum is minimum. So you have to just change the function and change the given part and you have to do. So now take down question number 3. Here the question, find the smallest possible value of x square plus y square given that x plus y is equal to 10. So what is given to us here? X plus y is equal to 10. And what is the smallest possible value? We are asking you to find the smallest possible value of x square plus y square. That means we have to take that as a function. X square plus y square as a function because it is talking about smallest possible value. That means the minimum value. Okay children? The function will be x square plus y square. And the given part is x plus y is equal to 10. So let's continue with the sum. Sum number 3. Write down given and so what is given? X plus y is equal to 10. It's already given to us. Put here x plus y is equal to 10. That's given part. Now I have told you that as soon as you write the given part, try to write out the value for y. So what is the value for y here? Y is equal to, this is 10 over here. I am going to shift the plus x to the right hand side. So you get here 10 minus x. Not write x minus 10. Okay, just put here 10 is already present here. So keep 10 first and take the plus x to the right hand side. It becomes 10 minus x. So from the given part, I have found the value for y. Now I am just going to write down the function over here. So what is the function? You have to find out the smallest possible value of x square plus y square. So f of x is equal to x square plus y square. And I have told you that we should not keep the function in terms of y because we are talking about f of x here. And we don't keep the function in terms of two variables. So this makes it a single variable. I know the value for y is. So this is x square plus y is 10 minus x, the whole square. It is x square plus 10 minus x the whole square. X square plus 10 minus x the whole square. Okay, try to expand it using the expansion. Expand 10 minus x the whole square. Okay. So what we get here after expanding, this is x square plus 10 minus x the whole square. So a minus b the whole square. I'll just do it directly. A square 100 2ab. So it's minus 2ab, so I get minus 20x plus b square, so plus x square. X square plus 100 minus 20x plus x square. We are just going to add here, we have only one like terms over here. So we are just going to add this, so I get here 2x square minus 20x plus 100. I found the value for f of x. It is 2x square minus 20x plus 100. So now you know what is the next step. After getting f of x, the next step is finding f dash x. After finding f dash x, you have to equate that with 0. Once you equate with 0, you will get the value for x. Once you get the value for x, you have to find out f double dash x. When you find f double dash x, you can find out whether it is maximum or minimum. Now here we have to talk about smallest possible, that means minimum. That means we should get a positive answer for f double dash x. After that, what you have to do? You have to just find out the value for y. And once you find out the value for y, the question here is to find out x square plus y square. So you have to find out x square plus y square also. Find out y and then you have to find out x square plus y square. So these are the procedures. Come on, try to do the sum. So you have written for fx, find out f dash x. Find out f dash x. I hope you are trying out f dash x. So what do you get? F dash x. This is 2 as it is. The 2 will come to the front. 2 minus 1, 1. So it's 2x. Derivation for x is 1. So I get the answer is 20. And derivative for a constant term is 0. So that's all. This is 4x minus 20. So we have found the value for f dash x, which is equal to 4x minus 20. So now you know the next step. Yes, we have to equate this with 0. Then on f dash x is equal to 0 implies 4x minus 20 is equal to 0. Implies 4x minus 20 is equal to 0. You can say therefore 4x is equal to 20. Therefore x is equal to 5. So we have found the critical value. X is equal to 5. So we have found the value for x. That's 5. Okay, now go for the next step. Find out f double dash x. Very easy. You have to just take the derivation of this term. Okay, f dash x is 4x minus 20. So you have to find out derivation of fx 4x minus 20. So f double dash x is equal to. See here, derivative of 4x is 4 and for 20 0. What is the answer? 4. Is it a positive answer? Yes. So you say it is minimum. It is minimum. It is minimum. Okay, done? Now, what do you have to find out? You have to find out the value for y. Just put here, y is equal to 10 minus x. So 10 minus 5, therefore y is equal to 5. So y is equal to 5. So I have found the value for x and I have found the value for y also. So we know both the values. Now what we have to find out? We have to find out the smallest possible values. Right now, therefore smallest possible value is, therefore smallest possible value is x square plus y square is equal to, I just put here. Okay, what is x square? 5 square. And what is y square? 5 square. So 25 plus 25, which is equal to 50. So this is the smallest possible value. The smallest possible value is x square plus y square is equal to 50. So we have completed our sum number 3. I hope we are clear with the steps. Just same procedure we are following. Yes, children? Just follow the same procedure and get your answers. So remember, the f double dash x will give you whether it's maximum or minimum. So there itself you will come to know whether your answers are correct or wrong. Okay, so this was the third sum, and now the fourth sum will be your homework. Mark down question number 4 as your homework, and now you will take up the fifth sum as your classwork. Copy down question number 5. Take down question number 5. Have you copied on the question? A rectangular page is to contain 24 centimeters square of print. The margins at the top and the bottom of the page are 1.5 centimeter, and the margins at other sides of the page is 1 centimeter. What should be the dimensions of the page so that the area of the paper used is minimum? Here we are talking about the area which is minimum. So what is the function here? The function is the area of the paper, and we have to get the value for f double dash x to be positive, because here we have to show that what we have here is given that area of the paper is minimum. That means I should get the answer as positive for f double dash x. Copy down the question. And just draw the figure. For this sum, we have to draw a figure. Using the figure, I will explain to you the question. Okay, children? So, just draw a rectangular page. And you have to just draw they're talking about the printed area. That means we have a margin over here. I think you would have seen the frames and all. So this is a rectangular page. This is a printed area. And this printed area is 24 square centimeter. The printed area is 24 square centimeter. Okay, and they are saying that, see here carefully, so this is the printed area and this is the whole page. This is the printed part and this is the whole page. I take this as x, the length as x, and I take the breadth as y. Okay, for the printed page, I am talking about the printed page, x and y. X is the length and y is the breadth of the printed page. And now they are saying the borders, the top of and the bottom. You see the question there? The margins at the top and bottom of the page are 1.5. So this is 1.5 centimeter. And the bottom part is also 1.5 centimeter. Okay, and on either side means the left side and the right side, they have given as 1 centimeter. Okay, so they have given as 1 centimeter. So this is the length of the printed paper. This is the breadth of the printed paper, and now this is the length of the full page. And this is the breadth of the full page. So I will find out the length of the full page. What is the length of the full page? This is x, and along with this x I have to add this 1 and 1. So it becomes x plus 2. Okay? And here how it becomes? This is y. Till here it is y, and this is 1.5 and 1.5. So 1.5 plus 1.5, y plus 3. So this is the breadth of the whole page, full page. So just complete the figure. Okay, now let's try to write out the statement over here. A rectangular page is to contain 24 centimeter square of print. Okay, so 24 centimeter square of print means you are being given with the area of the printed part. And what is the length of the printed part? X. And what is the breadth? It is y. So just write down here. Let x be the length and y be the breadth of the printed page. Let x be the length and y be the breadth of the printed page. So what I know? Area. So what is the area formula for a rectangle? Area for rectangle is x. Length into breadth. So here length is x and breadth is y. So I get xy is equal to 24. So this is given to us. Xy is equal to 24. Given part. Now once I know a given part, I have to just find out the value for y. So what is y here? Y is equal to 24 upon x. Just bring the x down. So y is equal to 24 upon x. Write out xy. After writing xy, you have to just write down the value for y, that is 24 upon x. Okay, now next thing is we have to write out the function over here. So just see what is the function. They are asking you the area of the paper used is minimum. Area of the paper means you are not talking about the printed part, but you are talking about the full page. Printed as well as unprinted. So this is the length, x plus 2, and the breadth is y plus 3. So you have to take this as the length and this as the breadth for the full page. So write down here, let f of x is equal to, again we are talking about the area has to be minimum. So length into breadth. So the length is x plus 2, breadth is y plus 3. So I have found the function f of x is equal to x plus 2 into y plus 3. F of x is equal to x plus 2 into y plus 3. I have told you that we will just keep the function in terms of single variable. So replace the value for y. So I get the answer as x plus 2. This is 24 upon x plus 3. I have just replaced the value for y as 24 upon x. Now very easy calculation, just go with the calculation. So x into 24 upon x. X gets cancelled. So what is left here? 24. X into 3. 3x. 2 into 24 upon x. 48 upon x. 2 into 3. That is 6. I'll just add these two numbers. So I get 30 plus 3x plus 48 upon x. I already have added 6. Yes? So I get 24 plus 6 is 30 plus 3x plus 48 upon x. So I have found the value for f of x. Okay, after finding f of x, what we have to do? We have to find out f dash x. I just have the figure. I hope you have taken on the figure. So I'll write out now f dash x. Derivative of 30 is 0, constant number. 3x, 3. I'll tell you how to find out the derivative for 48 upon x. Now what is 48 upon x? 48 upon x can be taken as 48 x raised to minus 1. This is upon x, okay? So when I take x to the numerator, it becomes x raised to minus 1. So how you write down? This 48 is as it is. So 48 minus 1 will come to the front. Okay. X minus 1. We have to, this is the formula. X raised to n is n into x raised to n minus 1. So minus 1 minus 1. What is minus 1 minus 1? Minus 2. So I get minus 48 x raised to minus 2. Minus 48 x raised to minus 2. So now this is in the form of negative power. If you bring it to the denominator, you get a positive power. So you get minus 48 upon x square. See, this is how you have to find out the derivative. So what is the derivative for 48 upon x? It's minus 48 upon x square. You can just take all the steps. So I have just taken upon x as x raised to minus 1. So keep 48 as it is. Minus 1 will come to the front. N. X minus 1 minus 1. So I get minus 2. So minus 48 x raised to minus 2. So this power is negative. So you can take to the denominator. So you get the answer as minus 48 upon x square. So I get here minus 48 upon x square. So I have found the value for f dash x. So f dash x is equal to 3 minus 48 upon x square. Take down the derivation. I have just explained you down. So copy down. Just work it out in the left side. Okay. Once you find f dash x, we have to just equate this with equal to 0. So put here f dash x is equal to 0 implies 3 minus 48 upon x square is equal to 0. So I get 3 is equal to 48 upon x square. So 3x square is equal to 48. 3 ones are 16. So x square is equal to 16. So x is equal to plus minus 4. But don't need to take the negative value because here we are talking about the length of the rectangle. So just say here negative value, or you can just say length cannot be negative. Therefore x is equal to 4. I got two values for x, plus minus 4, but we cannot take the negative value because we are talking about the dimensions of paper. So we have to take only the positive value. I get the answer for x as 4. Okay, now coming to the next step. So I have found f dash x, and using f dash x plus 0, I have found the value for x also. Now what is the next thing? I have to find out f double dash x. So f double dash x. Derivative of 3 is 0. So I will not write down here. So let's find out the derivative for 48 upon x square. So this is, I will just work it out here. See, 48 upon x square. I am not taking the sign now. I will take the sign later on. So this can be written as 48 x raised to minus 2. The power is positive here, so I have taken to the numerator part. It turns to negative. So this is equal to 48. You can keep it as it is. Minus 2 will come to the front. X minus 2 minus 1 minus 3. So this is minus 96. 48 into minus 2 minus 96 x raised to minus 3. So you have to write this as minus 96 upon x raised to 3. Again I am taking down to the denominator. So I get minus 96 upon x cube, and already I have your minus sign. So minus minus will become plus. So I get the answer is 96 upon x cube. Very easy. I am just applying the same formula x raised to n. So x square is changed to x raised to minus 2. Keep 48 as it is. Bring minus 2 to the front, and you have to just less 1 from here. So minus 2 minus 1 will give you minus 3. So this is minus 96 upon x cube. And we have already have one minus sign, so it will become plus. So the value for f double dash x is equal to 96 upon x cube. Here the value is not known to us. We don't have a proper value. I'll substitute the value for x. I know the value for x is 4. So put here f double dash 4 is equal to 96 upon 4 cubes. So 4 4s are 16. 16 into 4 gives you 64. No need to give the answer in decimal form. I know that this value is going to be positive. Just mention this is positive. You know, f double dash 4 is 96 upon 64, which is positive. Okay, so what you can say since it is positive? Yes, it is minimum. So it is x is equal to 4. It is minimum. Okay, we have found the value for x. The next thing is to find the value for y. What is the value for y? Y was 24 upon x. Therefore, y is equal to 24 upon 4, which gives you 6. So I have found the value for x also. I know the value for y also. Now, what is the question here? The question says that you have to find out the dimensions of the page so that the area of the paper used is minimum. Dimension of the page means I have to find out the dimension. I don't want the value for x and y. X and y was the length and the breadth of the printed paper. But I don't want the length and breadth of the printed paper. I want the length and breadth of the full page. So what is the length of the paper? So length of the paper is equal to x plus 2. Yes, we had like this, isn't it? This was x and we had here 1 centimeter. So it is x plus 2. So it is 4 plus 2 is equal to 6 centimeter. And breadth of the paper is equal to y plus 3. This side, the length side, we had your y and we had your 1.5 and 1.5. So y plus 3. So y is 6 plus 3 is equal to 9 centimeter. So we have found the dimension of the page. 6 centimeter and 9 centimeter. Okay, so this was question number 5. I hope you are clear with the derivations used over here. It's very easy. Understand the derivations properly. So when it is when you have a power, positive power in the denominator, and when you take it to the numerator, we get negative power. Yes. And once again, if you take a power which is negative in the numerator to the denominator, it will turn to positive. Just interchange. Positive will change to negative, negative will change to positive. So this was our sum number 5, and you have one more sum for homework. It is sum number 6. You are going to complete sum number 6 as your homework. So we have completed till sum number 5, and I have given you sum number 6 as homework. And we have some more sums in exercise 7.8, which will be continued in the next class.